Hey guys, welcome to my bedroom. I was just gonna do a video on the last part of this chapter instead of lecturing in class, and so we can have the whole time to work on our microscopes or their slides of the bacteria and stuff that y'all have grown at home. So I'm just gonna do a quick overview real fast. Remember, chapter 7's been all about microbiology. We've covered your main types of prokaryotes. We've got the archaea and the bacteria. Make up all the prokaryotes, and then of course the eukarya covers the eukaryotes. We talked about that. We talked a lot about how they use microscopes to study and about the history of those, how they use different stains to study microorganisms and all the different stains we covered. Differential stains, simple stains, gram-positive, gram-negative. Those are important. Those are pictures of those there. We covered all that. We talked about culturing and your broth cultures, which are liquid, and your agar, which is your solid cultures, which we swabbed last week, and then y'all are bringing in the broth cultures tomorrow. We talked about all that. We've talked about, just recapping, the different ways that they can live with oxygen and not oxygen, which we'll talk about that more in a minute. Archaea and the extremophiles, all the different types of those and how they live in really unique places. And science is still studying and figuring out their purposes all the time. We talked about the peptoglycan and how the archaea does not have them, but the bacteria does. And that causes them to stain differently. We talked about all that last week. I'm just recapping the chapter in general to give you a broad overview before we jump back in. And then we talked about more characteristics of bacteria, how they reproduce, their different structures, that the fact that they have endospores, which can cause them to live in harsh environments. You know, it was like that, I don't know, like a metal tank. Like they wrap themselves in the endospore so they can go dormant to survive harsh environments until they gets to somewhere where they could survive, and then the endospore will dissolve and then they'll go back to repopulating. We talked about all that last week. We talked about the different shapes here the bacteria can be in and what those mean. We talked about, we'll cover some of this in a minute, how some live in areas with oxygen, some live in areas without oxygen. Those are the obligate aerobes, obligate anaerobes, and how some can flip-flop. And those are your facultative anaerobes. We talked about all that. Talked about our immune systems. We didn't get much into serology, which is the study of the blood serum and all the different things we've learned from those. But that was last week in a really fast nutshell. And then the rest of the book goes just deeper into classifying different bacterias. But jumping back a little from that, let's talk about bacteria in general. So there's different ways we classify. We learned some of that last week. One is by their genus and species name, okay? And then even deeper than that, they will call them strains, okay? You heard that, oh, there's a new strain of COVID out. You know, a strain is a subtype of the organism within its own species group, okay? And it's sometimes called a serotype. But that's what a strain is, okay? It's an even more specific grouping of a organism, bacteria, whatever, within its genus and species name, okay? Genus, sorry. And then another way they classify bacteria, we talked last week, was the structure, is the coccus, bacillus, and this beryllium. We're going to see a lot of that in the lab. I'm assuming we'll mostly see coccus when we look at the stuff that we've grown, but we'll see. Maybe we'll spot some bacillus and berylliums too. Also, they're classified on the fact of how do they need oxygen. Do they need it? Are they obligate to get aerobes? Are they obligate anaerobes? Are they facultative anaerobes that can switch? That's another way they're classified. And they're also classified by how they stain. Are they gram-positive, which is going to be the ones with the peptoglycan that are purple. Gram-positives are going to be purple. Or are they gram-negatives, which is going to make them appear red because they don't soak up the gram stain. We have a visitor. Okay, and so that's how we classify bacteria. And then also, there's some important jobs that bacteria do that we've covered. One is our normal flora, which means that's where it should live normally, wherever that may be, whether that's in our mouth or on our skin, but they need to stay where they're supposed to stay. And when they get out of control, that's when they start to cause infections. Give me that lid. Mary Mabel, give me the lid. Our carbon cycle, a little bit about that. We really didn't talk much about it, but just how some bacteria actually produce carbon dioxide for the environment. Also, the oxygen cycle, we did talk about that. There are some bacteria that actually produce oxygen. That cyanobacteria produces 20% of our world's oxygen, which is really impressive considering that you can't see them with the naked eye and they produce that much. There must be a whole lot of them. And then another part of an important job that bacteria do is the nitrogen cycle. And that we do got to talk about a little bit. It's in your book. I suggest you read through it really slow and wrap your head around it. But the nitrogen cycle is some bacteria in the dirt are able to take the nitrogen from the atmosphere and turn it into molecules that organisms like plants can use. Organisms like plants can use. No, it's not Daddy. I'm going to have to pause this and come back. Sorry.